Hey guys, Mr. Jenkins back here to finish up, kind of give you your day 2 notes on 5.3. So just to recap, kind of we did the basics from your pre-algebra days. Understanding that y equals mx plus b, like how all that works. That m is the slope of a line, b is the y-intercept of a line. And then how that helps us to be able to graph a line if we're given an equation, and also write an equation for a line if we're given a graph. Those are the 2 main skills you need to be able to do. Okay. Past this lesson, we'll learn some new stuff, different forms of a linear equation. But for right now, what we did so far should be pretty much review. In Algebra 1, we always go a little bit more in depth than in your other lessons. So just kind of thinking out loud here, it would be a good thing for you guys to I always in my ideal scenario of you guys going through your learning, I want you to always watch the videos, but also I want you to use the notes. So like I skipped C and D. And ideally, what you could do on those is you could actually try C and D and then check them on the filled out notes. Okay, that is how you can kind of fully engage and do more than just the Math Excel problems where you can just ask it to show you how to solve it, right? Then you're truly almost doing it like a test question. Anyways, on that note, we'll go ahead and get started with the other examples that I skipped, example 4 and example 6. This is a skill that kids tend to struggle with, as I've seen in my past years, writing an equation from 2 points. So basically here they're just telling me that a line goes through 2, 1, and 5, -8. The directions say write an equation in slope-intercept form. That is your job to know eventually that means y equals mx plus b. That's called slope-intercept form. Good vocabulary term there. Of a line that passes through the given points. Okay, and notice we don't have a graph here. So one thing you could do if you had graph paper is to plot, 2, 1. That'd be like in there somewhere. And then 5, -8 would be like over here somewhere. And then you could do all the things we do. Okay, find the slope, find the y-intercept, and all that. But what we're going to do is find it algebraically. Okay, so the first thing that's a big difference here is that usually we talk about b first. Here we can't find b without m. Okay, so step 1 on these is to find m. So we could use the slope formula. That's the y2 minus y1. So -8 minus 1 over x2 minus x1. So 5 minus 2. Then we simplify. That's -9 over +3. A negative over a positive is negative. And then 9 over 3 is 3. So -3 is my slope. I can't do anything without that. Okay, and now we're going to basically use m to find b. All right, so I'm going to go back up here and give you guys kind of a shortcut. All right, so we've kind of done literal equations before. So what I'm going to do is basically take our y equals mx plus b and write that in terms of b. Okay, so if this were a test question, it might say, it wouldn't be on this test. It would have been on chapter 2 test, but it might say, for the literal equation, y equals mx plus b, solve for b. And that's going to help us with step 2. All right, so if I wanted to solve this for b, I want to move the plus mx over to the other side. So I am subtracting mx from both sides, which would give me y minus, y equals, meant to say y minus m times x is equal to b. All right, so we're going to kind of use that version of the formula to find b. All right, so on step 2, we're going to say b equals what we just figured out, y minus mx. I'm saying the right things today, but I keep writing the wrong things. All right, and then we're going to sub in some values, okay? So I have m. I know that m is -3, right? That's one value I'm going to use. And then I have a couple pairs of x's and y's, right? So I could use 2 and 1, or I could use 5 and -8. But you would want to use both together, right? Let's just use 2 and 1. All right, so when I sub in, we would get b equals, let's see, instead of y, we're going to sub 1. Instead of m, we're going to sub -3. And then instead of x, we're going to sub 2. So 1 minus -3 times 2. So that ends up being 1 minus -6. That's like 1 plus 6. So we get 7. All right, so if m is -3 and b is 7, now we have our equation of y equals -3 times x plus 7. -3 times x plus 7. Now, obviously that was a difficult process. So is there a way that we could check our answers? And the answer here is yes, you could, okay? So you could plug in x, so say plug in -2 and see if you get out for y, or sorry, plug in +2. So -3 times 2 is -6 plus 7 is 1. So this does map 2 to 1. Let's see if it does the same thing here. -3 times 5 is -15. -15 plus 7 is -8. So it works on both. I know I have the right response. Okay. I'm going to skip B. There is a built-in shortcut on B. So think about what I might be talking about. And I'm talking about example B. But also the letter B might be a clue. This is a good one to do and then check. All right. I will show C just so you can see that process again. All right. So again, first we have to find M. So for people who are using stack them and subtract them, I'll show my work a little bit differently here. I'll stack them and subtract them. So -3, 3 stacked over 1, 2. Doesn't matter which way you stack them. Now I'm going to subtract them. So my rise is 3 minus 2 is 1. My run is -3 minus 1 is -4. And then my slope then is rise over run, so 1 over -4. We would kind of simplify that as just -1/4. One's positive, one's negative. All right, so this is going to be a little bit tougher because of the fraction, but that's okay. If we're using our calculator, that might be simpler to do -0.25. All right. So step 2 then, we're going to use our nifty formula, b equals y minus mx. So we're going to sub in -3 for x and 3 for y. So b equals y, which is 3, or we could have subbed 1. Or sorry, we could have subbed 2. Minus m, which is -1/4. Times x, which is -3. Or if we would have subbed in 2, that would have been 1. Okay, so 3 minus, that's going to be positive. This obviously would be something you would punch into a calculator, but that's going to be, I'm just looking at it real quick. That would be 3 minus 3/4. So that's going to be b equals 2.25. So really a tough one there, but you know, you would use a calculator to do that. You would just type 3 minus -1/4 times -3. All right, you wouldn't want to try to come up with that in your head. So I have m, I have b. So we sub it all in. Y equals -1/4 x. And I could write plus 2.25. I would accept that. I'm going to write that as a fraction. So 2 1/4. I'm going to write as plus 9/4. I think that's what it probably says on the notes. But 9/4 is equal to 2.25. All right, so really a tough one there. B is a little bit more like what you might see on a test. All right, then going down to example 6, kind of our word problems. So A says, suppose you have a $5 off coupon at a fabric store. You buy fabric that costs $7.50 per yard. Write an equation that models the total amount of money Y you pay if you buy X yards of fabric. So there they've already defined our variables for us. So Y is the amount we pay in dollars, and X is the amount of fabric we buy. And yards. All right, so we're going to use the numbers 5, actually -5 because it's $5 off of what we spend. So it's going to be a -5. And then the cost is $7.50 per yard, so that's going to add to our cost. So then we want to figure out which one of these is M and which one is B. That's an important skill. So B always just happens once, or it's our initial starting point. If we buy no yards of fabric, then what would we spend? And in theory, this wouldn't really happen. But in theory, we would spend -$5. The coupon is what happens once, and then the $7.50 is what happens. Depending on, it happens repeatedly depending on how many X's we buy. So that's our rate of change. All right, so overall then our equation would be Y equals 7.5 times M minus 5. And I don't love this problem because if my y-intercept is down here, then it's going to be a little bit difficult to graph using M and B. So I'm gonna use my imagination a little bit. So we're gonna call this 0, 5, even though it's a little bit off of our graph. Sorry, -5. And then the slope is a little bit difficult to use too. So y-intercept was 0, -5. M is equal to 7.5 over 1. If we actually kind of scale that up a little bit, if we double both and make that 15 over 2, now it's a slope we can use. Okay. The last thing I would mention is that we are counting by 5s here. Okay, because that says 10, that says 20, and we're counting by 1s here because that says 2, that says 4. So my rise of 15 is 5, 10, 15. Looks like a rise of 3, and then I run 2. Okay. I know I rose 15 because I went from -5 up to 10. You got to pay attention to the numbers there. Rise another 5, 10, 15, run another 2, and then maybe do one more. 1, 2, 3 over 2. All right, so in this case, we'll assume that we could buy partial yards of fabric. So I'm going to go ahead and make this a continuous function. However, I'm not going to go all the way down here because that would literally mean they paid you for giving them a coupon. That's not going to happen. So I'm just going to go from here with my straight edge down to the last part where it makes sense. So like right in there. All right, so, these word problems kind of put it into context a little bit. These are kind of nice. This tells me if I buy 2 yards of fabric, I pay $10. If I buy 4, I pay $25, and so on and so forth. But what's cool about these lines is it also tells me, you know, if I buy 2.5 yards of fabric, I'm going to pay, you know, somewhere between $10 and $15. So that's kind of a neat thing about the lines. All right, and then our last example, kind of notice we don't have a graph on this one, so we will kind of answer this without a graph. But the big thing here would be being able to write your linear equation. It says Mr. Huyen wants to join a gym as part of his New Year's resolution. The local gym in his neighborhood charges an initiation fee of $75. Mr. Huyen will also have to pay a monthly fee of $50 to use the gym. Let C equal the total cost. So there they've defined one variable for me of the gym membership, and let M equal the number of months he uses the gym. Write an equation that models the situation. And then we're going to use that to answer the second question. The big part of this one, though, is, you know, we know we're going to use C and we're going to use M, but, you know, does it say, is our equation going to say C equals, or is it going to say M equals, right? So a lot of people struggle with that. So the question is then, does cost depend on the number of months, or does the number of months depends on the cost? And that would be, the correct answer to that would be that the cost depends on how many months we go to the gym. So that tells me that C, it's going to say C equals. C is a function of M, okay? So that's the first thing. It's going to say C equals. Now, C equals what, right? So now we go back and look at our numbers. We have this monthly fee of $50. So that's going to add to our total cost. And then also this initiation fee of $75. That's going to add to our total cost. So which one's B and which one's M? So our initiation fee, that's our initial value, what we pay one time, that is B. And so 50 must be M, which makes sense because that is our monthly fee. That's our rate. Okay, so we put everything together. C equals 50 times M plus 75. That's the biggest thing about this problem, guys. And then we'll just use that to answer the next question algebraically. If he has paid $525, how many months has he attended the gym? So what you need to figure out on this one is $525, an M value or a C value. It's a cost value. So that would be where C equals $525. We're going to find M. Okay, so usually we want to sub in there, but they give us a cost. So it'll end up looking like this. 525 equals 50M plus 75. Go ahead and subtract your 75 from both sides. That's going to give me 450 equals 50M. And then divide both sides by 50. 450 over 50, I think of that as 45 over 5. So I know that that is 9 months. So his New Year's resolution did not last too long. So anyways, you don't have a new assignment. Your assignment is still the same as it was, but now we've covered every type of example. And guys, remember, this stuff is super important. This is the big unit of this quarter. So anyways, ask questions if you have them. Let me know what I can help you guys with. And the main thing is just stay engaged and you know, keep trying and you know, ask those questions if you have any. Thank you and have a nice day.